Hello students, welcome back to our series on complex numbers. This is part 2. Today we will study modulus, argument, polar and Euler forms, De Moivre's theorem, powers of I, roots of complex numbers, and roots of unity. Let's begin. Modulus of a complex number if z equals x plus iy, the modulus of z written as modulus of z is equal to square root of x squared plus y squared. It represents the distance of the point from the origin in the Argand plane. Examples. 1. If z equals 3 plus 4i, modulus of z equals square root of 3 squared plus 4 squared equals square root of 9 plus 16 equals square root of 25 equals 5. 2. If z equals minus 5 plus 12i, modulus equals square root of minus 5 squared plus 12 squared equals square root of 25 plus 144 equals square root of 169 equals 13. 3. If z equals 2 plus 3i, modulus equals square root of 2 squared plus 3 squared equals square root of 4 plus 9 equals square root of 13.
Sir, why is modulus so important?
Good question. Modulus represents the length or distance of the point from the origin. It is widely used in geometry of complex numbers and in representing numbers in polar form. Argument of a complex number. Argument of z, written as argz, is the angle that the line joining the origin to the point makes with the positive x-axis. Examples. 1. If z equals 1 plus I, argument equals tan inverse of 1 by 1 equals 45 degrees. 2. If z equals minus 1 plus I, then the point is in the second quadrant. Argument equals tan inverse of 1 divided by minus 1 equals minus 45 degrees, but we add 180 degrees for quadrant, so it becomes 135 degrees. 3. If z equals minus 2i, the point is in the third quadrant. Argument equals tan inverse of minus 2 divided by minus 2 equals tan inverse of 1 equals 45 degrees plus 180 degrees equals 225 degrees. Polar form. A complex number can be written in polar form as a multiplied by cos theta plus I sin theta. Here R equals modulus of z and theta equals argument of z. Example, if z equals 1 plus I, then modulus equals square root of 1 squared plus 1 squared equals square root of 2. Argument equals 45 degrees. So polar form is square root of 2 multiplied by cos 45 degrees plus I sin 45 degrees. Euler's form. In Euler's form, we write z equals r e raised to the power I theta. This is a compact way of writing polar form. Example, 1 plus I equals square root of 2 multiplied by e raised to the power I pi by 4.
Sir, why is Euler's form more useful than polar form?
Excellent doubt. Euler's form makes multiplication, division, powers, and roots very simple because we only need to add or subtract arguments and multiply or divide moduli. De Moivre's theorem. According to De Moivre's theorem, cos theta plus I sin theta raised to the power n equals cos n theta plus I sin n theta. Examples. 1. Cos 30 degrees plus I sin 30 degrees raised to the power 3 equals cos 90 degrees plus I sin 90 degrees equals I. Examples. 1 plus I raised to the power 8. Step 1, write 1 plus I in polar form and square root of 2 multiplied by cos 45 degrees plus I sin 45 degrees. Step 2, raised to power 8, square root of 2 raised to the power 8 multiplied by 16 multiplied by, since cos 360 equals 1, sin 360 equals 0. Final answer, ings 16. Powers of I. The powers of I repeat in a cycle of 4. I to the power 1 equals I squared equals minus 1, I cubed equals minus I to the power 4 equals 1. Examples. 1. I to the power 23. Divide 23 by 4, remainder is 3. So value equals I cubed equals minus I. 2. I to the power 2025. Divide by 4, remainder is 1. So value equals I. Roots of complex numbers. The nth roots of r cos theta plus I sin theta are given by r to the power 1 by n multiplied by cos of theta plus 2kp, divided by n plus I sin of theta plus 2k pi, divided by n, where k equals 0, 1, 2, up to n minus 1. Example. Square roots of I, step 1, write I in polar form, I equals cos 90 degrees plus I sin 90 degrees. Step 2, square roots are modulus equals 1 to the power 1 by 2 equals 1, arguments equal 90 plus 2 kpi, divided by 2. 4k equals 0, angle equals 45 degrees. Root equals 45 plus a sin 45, 1 by square root of 2 plus I by square root of 2. 4k equals 1, angle post 90 plus 360, divided by 2, 225 degrees. Root cos 225 plus I sin 225 minus 1 by square root of 2 minus I by square root of 2. Roots of unity are the solutions of z to the power n equals 1. Example, cube roots of unity. Solutions of z cube equals 1 are z is equal to 1, z is equal to minus 1 by 2 plus I root 3 by 2, and z is equal to minus 1 by 2 minus I root 3 by 2. An important relation, 1 plus omega squared equals 0, where omega is a cube root of unity.